We are going to continue solving quadratics by factoring today. And so again, you've seen this before. You're going to make sure you write in standard form, and we're going to see several examples today where we're not in standard form to start off. So we do need to make sure we're doing that first. Remove a greatest common factor if you have one, and then break down into its factors. And so the factoring today is going to be a little different than what we saw before because we are not going to be left with a quadratic that has a 1x squared as its leading coefficient. So that makes the breaking down into factors a little bit more involved. So here's an example. The first thing that we have to do here is set this quadratic equal to 0. So I need to add the 8 to both sides. And then I want to look at all of my terms and see what my common factor might be or what I can divide out of all three terms. So I'm not going to be able to divide out the 48 because if I try 248 divided by 48, that's not divisible. But let's see what I can find here. It looks like I can divide an 8 out of all three terms. So if I take all of these and divide out an 8, I can pull that 8 out front, and then this is going to leave me with a 6x squared. 248 divided by 8 will be a 31x, and then 224 divided by 8 will be a 28. This is now what I want to try and break down into two sets of parentheses. So I'm going to take this and just recopy it over here. So what I need to think about are ways that I can multiply to get a 6x squared. So I can get a 6x squared from either 6x and 1x or 2x and 3x. I also need to think about ways that I can get a 28. So I can get a 28 from 1 times 28, 2 times 14, 4 times 7. And so what I need to do is I need to figure out what combination of these two paired with what combination of these two will give me outside and inside terms that will combine to give a negative 31x. And so it's a little bit of trial and error here. I'm going to set up my parentheses, and maybe I try my 2x and 3x first. And then maybe I try 4 and 7. So what I'm going to do is I'm going to put the 4 and 7 in here, but I want to look at my outside and inside terms and see if there's a way that I can get a negative 31x from them. So 2x times 7, that gives me a 14x from my outside terms. 4 times 3x gives me a 12x from my inside terms. So if I were to combine these either through addition or subtraction, there's no way I'm going to get a negative 31x out of them. So that combination is not going to work. So maybe then what I do is I try and switch. Oh, that's a highlighter, not an eraser. Here we go. I try and switch my 4 and my 7 and see if that changes things. So now outside I have 14x and inside I have 21x. I'm still not going to be able to add or subtract those to get a negative 31. So that means the 4 and the 7 is not going to work with the 2x and 3x. So maybe then I try switching it up a little bit, and maybe I'll do the 2 and 14. So say I do a 2 here and a 14 here. My outside terms are 28x and my inside terms are 6x. So that's not going to add or subtract to give me 31. So then maybe I could try and switch them. I could put my 14 here and my 2 here, but that's going to give me a 4 here. And then this is going to give me a 42 when I multiply. So that's not going to give me a 31 either. The 1 and 28 Probably not going to work because that 28 is pretty big. So maybe I have to switch it up, and maybe I have to try the 6x and 1x instead of the 2x and 3x. And again, like I said, this is some trial and error, and it will get easier as you get some more practice. You'll start to recognize things that will work faster than others. Okay, so switch back to my pen here, and I said I'm going to try a 6x and 1x, and then maybe I try that with the 7 and the 4. So here, my outside terms are 24x, my inside terms are 7x. This is going to work for me. If I have a negative 24x and a negative 7x, those will combine to give me a negative 31x. So I need a negative 7, negative 4. So then once you figure out what combination works for you, it's the same as it was before. We set those parentheses equal to 0 and solve for x. So over here, you're going to add 7, and we've got 6x equals 7, and then divide by 6 to get x equals 7 over 6, and we're just going to leave it that way. Over here, you just add the 4 to get x equals 4. So again, another example where we're not in standard form, so we need to make sure that we do that first. So I'm going to add that m squared and subtract the 5m. So that'll leave me with a 15m squared. Here that will be a plus 26m plus 8 equals 0. So now this one's a little different from the last one. 15, 26, and 8 don't have any common terms. So we're going to go ahead and jump straight to the two sets of parentheses. Again, thinking about I can get 8 from either 1 times 8 or 2 times 4. I can get 15 from 1 times 15 or 3 times 5. And my outside and inside terms have to combine to give me that 26. So maybe I try 3m times 5m to give me 15m squared. And then maybe I try the 2 and the 4. So maybe I put a 2 here and a 4 here. Well, this is going to give me a 12 from my outside terms and a 10 from my inside terms. So that's not going to work. But maybe if I switch them, my outside's 6 and my inside is 20. So you don't have to write this out, but sometimes I think it helps students. My outside terms are 6m, my inside terms are 20m. I need them both to be positive to match this 26m here. So both of these are pluses. So I have 3m plus 4 equals 0 and 5m plus 2 equals 0. So I'm going to subtract 4 and divide by 3. So I get m equals negative 4/3. Over here, I'm going to subtract 2 and divide by 5. So I get m equals negative 2/5. All right, so another one here, again, making sure we set it equal to 0 first. So I'm going to subtract a 5m squared and add a 95m. Oops, plus 95m. And so you can see that on the left-hand side there wasn't an m term, so you're just going to squeeze that into its standard form location. So here this is going to be 105m squared plus 95m minus 60 equals 0. This one has the greatest common factor. So in this case, we can divide everything by 5. That 5 goes out front. And then we have 21m squared, 19m minus 12. I'm just going to rewrite that here. So again, we want to break that down into our two sets of parentheses. So thinking about the 21 being a 21 and a 1 or a 7 and a 3. The 12 could be a 12 and a 1, a 2 and a 6, or a 3 and a 4. So maybe I try the 7M and 3M first, and then just kind of thinking through this list, if I put my 3 and my 4 in, if it helps to see, we can put those in. My outside terms are going to be 28. My inside terms are going to be 9. So that works out for us. So if we've got outside 28M, inside 9M, my goal is to get a 19M here. I need a positive 28 minus 9 to get a positive 19M. So this 19M here, we just have to go back and put our signs in, and this time they're different, so we do want to be careful. The 9M is negative. That came from 3 times 3 here, so it needs to be a negative 3 times 3. The 28 is positive, so that's a 7M times 4, which would have to be positive to make it a positive 28. So now each set of parentheses gets set equal to 0. Over here, we're going to add 3 and then divide by 7. So 7M equals 3. M is going to be 3 over 7. Over here, subtracting 4. And then dividing by 3, we get negative 4/3. Another example here, let's get it in standard form. We can subtract the 2k squared and subtract the 5k, add the 5, and we're doing all those things over here. So minus 2k squared minus 5k plus 5. So here, 4k squared minus 2k squared is going to be a 2k squared. Negative 5k didn't have a like term, so we're just going to squeeze it in there. Negative 3 plus 5 will be a plus 2. So again, this is one that's similar to the second problem that we did. There is no greatest common factor. And there's not as many options to try here. 2k squared is just 2 times 1. 2 is just 2 times 1. We just have to figure out where the 2 goes and where the 1 goes so that our outside and inside terms give us negative 5k. So 2k times 1k to get the 2k squared. And then I'm going to need to put my 2 here and my 1 here so that my outside terms give me 4k, my inside terms give me 1k. They both have to be negative so that when I add them together, I get the negative 5k that I have in the center here. So 2k minus 1, k minus 2. So 2k minus 1 equals 0. We're going to add the 1 and then divide by 2. We get k equals 1/2. And then k minus 2 equals 0. We add the 2 and get k equals 2. Again, standard form first. Even if you just have something where the variables are out of order, you want to make sure that you do that first so that you're correctly lining everything up for your factors. Don't try and get lazy about it and skip that initial step. So 20k squared, and then combining here, we have negative 31k plus 7k, so that's going to be a negative 24k. And then negative 38 plus 6, so minus 32. So here we have a greatest common factor of, it looks like 4 that we can remove from all 3 components. So 20k squared divided by 4 will be a 5k squared. 24k divided by 4 will be a 6k. And then 32 divided by 4 will be an 8. Now, 5k squared is just going to come from 5k and 1k. 8 could be coming from 1 and 8 or 2 and 4. Again, those outside and inside terms are going to have to give us negative 6. So we know this has to be 5k and k. There's no other options for that 5k squared. For the 8, again, we have those options of 1 and 8 or 2 and 4. So one thing we can start to think about is that if I tried my 2 and my 4, I don't want to put my 4 over here on the right because it's going to get multiplied by that 5 and give me 20. I'm trying to get a 6k. And if I have 20, I'm going to have to be subtracting something pretty big from it in order to get a 6. So maybe if I want to try the 2 and the 4, I would put the 4 here and the 2 here instead. Now my outside terms are a 10k and my inside terms are a 4k. I need a negative 6. So if I have a negative 10k and a positive 4, Those will give me a negative 6k. So then to go put those signs in, the 10k came from the 5 times 2, so it needs to be a 5 times negative 2. And then the 4 was the 4 times k, so it needs to be a plus 4. So then 5k plus 4 equals 0, and k minus 2 equals 0. Over here, you're going to subtract the 4 and divide by 5. So we get negative 4/5. And then over here, just adding the 2, we get k equals 2. Okay, so another one here. And so you might be wondering, I've kind of been moving everything to the left-hand side. You want your squared term to be positive if you can. So I'm going to move that 3v squared over to the left and move everything else over. So we've got minus v, and then it's going to be a plus 3v squared plus 42. Okay, so that will be 3v squared plus, a minus v. Just put a plus negative v. Plus 42 equals 0. Oh, I forgot to subtract it from the 26. Let me fix that v term. Okay. So 3v squared, and then we had the 26v minus v, so that'll be a minus positive 25v. And then plus 42. All right, so no greatest common factors here, so this is going to be a 3v times v. That's the only options. 42, we have quite a few options. We've got 1 and 42. We've got 2 and 24. We have, let's see, 3 and 14. We've got 4 and, nope, not 4, not 5, but we've got 6 and 7. Okay, so 3v times v for the 3v squared. And then we just work our way through the list again. So the 6 and 7, maybe we try that. And you can start to mentally check these. You don't have to write them and erase them every time. I'm doing that just so that you guys can see where the numbers are coming from. So I put the 6 and 7 in. This is going to be a 21. This is going to be a 6. So I can't combine 21 and 6 to get 25. But maybe if I flip them, now I have 18 for my outside terms. And then my inside terms are 7. If I add 18 and 7, that'll give me a 25v. So this is my combination here. I need it to be positive, so 3v plus 7, v plus 6. And then I just set those equal to 0. So 3v plus 7 equals 0. I subtract 7 and divide by 3 to get negative 7/3. And then v plus 6 equals 0. I subtract 6 to get negative 6. All right, one more example here. Again, set it equal to 0. This one we just have to subtract the 3. So 9x squared plus 27x plus 14 equals 0. Here, the 9x squared could be a 3x and 3x, or a 1x and 9x. 14 could be 2 and 7, or it could be 1 and 14. I'm going to try the 3x and 3x first, and here's why. My outside and inside terms, it doesn't matter what order I put these in, because in both cases I'm multiplying them by 3x. So it makes it a little quicker to eliminate from this list. So if I put my 2 and my 7 in, outside I have 21, and inside I have 6. So outside's 21x, inside is 6x. I want to add those to get 27. So they both need to be positive. So 3x plus 2. 3x plus 7. So 3x plus 2 equals 0. I'm going to subtract 2 and divide by 3. I get negative 2/3, and 3x plus 7 equals 0. I subtract 7 and divide by 3 to get negative 7/3. Okay, so there are a few more examples here. We'll do some of them tomorrow in class, but for your assignment tonight, you're going to try factoring worksheet 4. Some of the questions on factoring worksheet 4 don't have a greatest common factor and look like what we did in class today. Some have a greatest common factor and then go back to what we did last week, or maybe they're a dots pattern. So give those a shot, and then we'll go through some more factoring practice the next couple of days.